The goal of the project is to present the advantages of the use of QDisk for the raw data transfer, and also to show how the use of QDisk eliminates the problem with bursts of traffic. What is a QDisk? QDisk is also called a queuing discipline, is the building block of Linux traffic control. QDisk is a scheduler and will rearrange the packets entering the scheduler's queue in accordance with the scheduler's rules in order to eliminate traffic bursts. eView. eView is a distributed visualization application that uses remote I/O eView data to access data across. eView data uses the UDP protocol for low-level data transmission. What is UDT? UDT is a UDP-based data transfer protocol, and these are the results of the initial base case comparison, initial tests what we have done. These tests include the IPOF UDP test, which has a throughput of 8.46 Gbps, and the next we have done is the IPOF TCP. So, as you've seen, IPOF TCP throughput is less when compared to the UDP. This is the experimental scenario what we have considered. We have multiple senders sending the data, that's the raw data, to a single receiver. Here the sender 1, sender 2, sender 3 up to sender n. This is the next case of single sender sending data, raw data, to a single receiver. And here are the IPOF results with and without the use of QDisk. And now let's check the eView results. Single sender sending data to a single receiver. When you've seen the throughput with the use of QDisk of value 4 Gbps, the throughput has increased. The increase is of 12%. Next we'll see the distributed visualization, how the QDisk affects the distributed visualization. Sage is used by the eView to transmit images from the remote rendering module to the client. So what we are looking right now is the TCP image. The image formed by the TCP way of transmission on the Sage display. Let's run the image again so we can see the entire loading part. With the use of TCP transmission, when you look at the frame rate is very less. It is like averagely 3 frames per second. With the help of VNC server, the image also rotates, and it rotates smoothly. So like here we observed that it nearly took 18 to 20 seconds for the image to rotate. This is the TCP way of transmission. Now we're going to look at the UDP way of transmission of the images from the remote server. As you see, the image is getting loaded, and this is a UDP way of transmission. See, the loading of the image got stopped at a particular point. The frame rate is 15 frames per second, and it is like on an average the frame rate is 15 frames per second, and the image is good, but the image is frozen. It's like with the help of VNC server we won't be able to move this image, and it's frozen. Next we'll place the QDisk, and we will use the same UDP way of transmission and see how the QDisks help the UDP way of transmission. For the experiments of QDisc, we need to place the QDisc on all the 8 nodes. These are the 8 nodes which are used for the parallel streaming of this visual. So here are the commands. And these 2 commands are executed as root on these systems, and these need to be executed on all the 8 nodes. Once you have placed the QDisc on all the 8 nodes as shown previously, let's run the UDP way of transmission with the QDiscs in place. As you can see now, the image is getting loaded. Now the image is fully loaded. Let's see what is the frame rate. See, the frame rate is nearly 6 frames per second. Now let's try to rotate the image using our VNC server, and it took like nearly 2 seconds to rotate, and the image is completely visible. I mean, it's completely loaded within 3 seconds. So on an average, like, this is what we got, like, by repeating this experiment over time. So in this UDP way of transmission with the QDisc in place, we were able to solve the problem what we had with the UDP way of transmission without the QDisc.